Good afternoon, Professor. So right now my group and I are honored to be here to talk about our finals projects that is related to the movie recommendations. And I would like to introduce our group member, which are Soonly, Kunthea, and Socheata. It is me. So let's move to the next part. It is a table of content. And we start the introductions, and then we goes to objective and motivations. After that, we go to the type of recommendation system and workflows. And the last one, we would talk about the PDLC press and code demos and the future developments. Let's move to the start the introductions. Before that, I have some questions to ask you. That have you ever wondered what kind of the system that Netflix used to recommend to the next movie? That's mean like when you watch the Netflix video or movie, you always see like at the end of the video, they have another video to recommend you to watch that video. So do you wonder about that? Or one more thing, when you watch the Facebook or YouTube, they also have another recommendations videos for the next when you watch at the end of the video. And also Facebook, like when you watch example, like when you watch Chinese videos, then when you scroll down, they also have another Chinese video again and again and again. So what's that? Do you wonder? I would like to show you about that. It is kind of like the recommendation system. So what is recommendation system? The recommendation system is kind of like the checks to estimate and predict user content preference regarding the games, stories, or videos. And the system draw from data usage history, aiming at the making suggestions based on the user interest. And then let's move to the objective and motivations. Let's talk about the objective. What is objective? The objective of recommender system is to provide recommendation based on records information on the user preference. Like I said, it will records all what you watch, then it's recommend you to the next videos. And the motivation is the recommender system are really critical in some industry, as they can generate a huge amounts of incomes when they are efficient, or also be a ways to stand out significantly from competitor. Okay, let's move to the next slide. That is, yes.
Sorry, I forgot to unmute my mic. So the movie recommendation system uses a set of different strategy and algorithm to help user find the most content film or the movie. And the most popular type of algorithm used in the movie recommendation include content-based recommendation system and collaborative-based recommendation system. So can you go to the next slide? So a content-based recommendation system uses the data provided about the movie. The data in here plays such an important role as we get it from only one user, and as a algorithm use this strategy to recommend a movie that are similar to the user preference in the past, and therefore the similarity in the content-based recommendation system is generated by the data about the past film that the user watch. But how does it work? Well, the recommendation system analyze the past preference of the user concerned, and then use this information to try to find a similar movie for the user. And this information is available in the data set. And in the data set, we have information such as like director, genre of the movie, or the lead actor, something like that. And after that, the system provides the movie recommendation for the user. So the core element in the content-based recommendation system is only the data of only one user. that used to prediction. And another one, we have the collaborative best recommendation system. So the system is based on combination of the relevant user and other user behavior. And the system compare and contrast the behavior of the most optimal result, and it's a collaborative of multiple user, film preference and behavior. But what is the strategy or the algorithm? Well, the core element of this movie recommendation system and the algorithm is built on the history of all users in the data set. So basically, collaborative recommendation system is based on the interaction of all users in the system with the movie. So it's mean like every user impact on the final income of this best recommendation system, while content-based recommendation system depend on the data we get from one user. So can you go to the next slide? So now let's try to understand what is the workflow that we are going to follow for this project. So first we have to collect the data set. Well, we need to have the data of the movie and several details about the movie, kind of the actor, the genre, and the director, something like that. And after that, after we collecting the data, we need to process the data. And here it means like we need to pre-processing the data by checking the data is any of the data value are missing or not. And for the next step is the feature extraction. The main thing about the movie data set is that all of the data will be in the form in the text, so we cannot use them like directly. We need to turn them into the feature factor. And after that, we will try to get the user input. So when we get the user input, then we will try to find the similarity score between the movies. So let's say like we have about 1,000 movies on the data set. And in here, we will try to find which movie are similar to each other by giving them a similarity score. So when we do that, we need to ask the user to give our input. And when we get the input, we will find the similarity between them by using the causing similarity algorithm. And after that, we will get the result and give the user some movie recommendation. Can you go to the next slide? So here is our PDLC page. So we have problem analysis. Our problem analysis is to recommend movie to the user, and we use the data set, and then we calculate the movie into the vector and then display the result for the user in our program design. And then we use Python machine learning for our programming coding. For the for program debugging and testing, we've been testing it all along the way in case like is there any error or not, but it is not. We have been testing so many times. And for the program implementation and maintenance, we use the UI-based program. So let's move to the next slide. Here's our code demo. Before we jump up to the code demo, let me talk last one about the future development. And here, for our future development, we want to increase the data size of our movie recommendation in case we will get like the more accurate movie, and then we want to have a better design. As now, it's not, we don't have any GUI or UI quality. Yeah. So I'm gonna turn this to Soonly.
Okay. Yeah. Stop sharing. 1 second. So now the code demo. So the thing about the code, okay, let's start from the top. So of course, with anything when you study data, when you have to mess with data, first of all, you need to collect data and processing. So we have the data in this link right here. So we will also provide the link, provide this comma separated value file with our submission. But the thing is that this is gonna be our main database for our final project. And of course, with any data science, we need NumPy, Panda, diff library. We also need to get vectorizer and cosine similarity, because the way that we compare our data is by first of all somehow turning it to vector, and then by using I think was it dot product or something, would allow it to turn into cosine, and then we compare how similar the cosine values are. So of course you have read the data, you have getting the head, turning into a shape that we could read, that Python could easily read, and then we have our selected features, which includes genre, keywords, headline, cast, and the vector. And then now we started. So the thing is that now we would print. We would narrow down our data to like the selected features. Then once we're done, we're combining all the 5 selected features, so movie data, movie keywords, movie tagline, cast, and director. And then now we have to use vectorizer as a function. So now we start to we use a vectorizer to turn like the combined features, whatever we have here, into a vector. And then once we have the vector, we can take the cosine formula, and we will apply the vectors that we added in. And then once we're done with that, we now have to get the input from the user. So now, and once we get the input, which is named by as movie name. So, so the thing is that now it would first generate like a list of all the movie names given in the data set, and then it would find a close match as close as possible from the movie name and lists of all titles. And then it will close match to once it finds close match, it will start with the index 0. And then the index of the movie is basically, I guess, yeah, that's the function. It's like to get the index of the movie with the title of which is similar and which is not. And then now we have to turn this into a list. So we can get a similarity score. We have a list like this. You have the index of the movie into the similarity list, and then you enumerate that into a list. And you get the length of the similarity score. I mean, like this, we are supposed to print this, but I forgot to comment that part out. Sorted similar movies means that we have to, okay, now we have the scores, but now we need to sort on like which movie are the most similar and which is not. And then these are just like some of the parameters that we use. And then finally, we can print out the movie. So using a for loop, we can print out the movie in like the sorted list. So index movie 0. And then after that, we keep on printing and so on. So if I run the program, 1 second. If I run the program, please give it a second. It's kind of slow. Um, 1 second, it's still running. So let's say my favorite movie is, say, Iron Man, for example. So Iron Man, it will show on the top 10 because in this case we decided to do on the top 10. So it's Iron Man 2, Iron Man 3, Avengers Age of Ultron, which I think except for number 10, they're all pretty much in the same universe. They have pretty much the same directors, the same studio. So at least for this one, I would say it's fairly accurate. Let's say if I want to get another film, let's say, let me think of a good film to place it in. To say Harry Potter. Oh, so the thing is that because Harry Potter is not in the database, it just shows you what are like really similar to the movie that I'm trying to find. So this is in a case where the movie is not in the database. So as we said before, the best way to improve this is by adding GUI or implementing it into like say a web app like Netflix or YouTube, whatever that needs video playing. And then we also have to expand the database because the data set that we have right now, it's very limited. So thank you for listening to our presentation, and any questions could be put in the comments below.